Hello students.
Yes, sir.
So today we are going to discuss about heat transfer. Okay. So you have a subject called heat transfer. Am I right? Okay. So in that heat transfer we have to now discuss about the basics. Okay. We start from the thermodynamics. Okay. So what is do you know about the basics of thermodynamics, like zeroth law of thermodynamics, first law, second law? Do you have any idea?
Yes.
Okay. So zeroth law. Do you have any idea about zeroth law?
Every
So it is like zeroth law will describe about thermal equilibrium. Generally, it will discuss about the thermal equilibrium. So thermal equilibrium, like if I have a water bottle having a water of about around 20 degrees centigrade, and in my another hand, if I having a water it's around 30 degrees centigrade. Okay, what if I mix both of them? What will happen? Here in the water bottle, I am having the water at 20 degrees centigrade, and in my another hand, I am having 30 degrees centigrade. Okay. If I mix both of them, what will happen?
it will equilibrate and equal to 0.
Okay. It will try to mix together, and the temperature of higher temperature, that is the hot water, will become reduced. Okay. So both of them will try to attain a common temperature, that is thermal equilibrium. Okay, so zeroth law will discuss about that. And the first law? Okay, second law. So it's like second law, it's like it's talking about the entropy. Okay, or it is talking about the temperature. Okay, so generally heat will transfer from higher temperature region to lower temperature region. So this concept is the basics of heat transfer. Okay, so where it starts from the basics of thermodynamics, and this will connect to your subject called heat and mass transfer. So in particular, that heat transfer, that is heat is a form of energy, that you know that. Okay, and temperature is a property. It will measure whether that particular substance is hot or cold. Okay, so heat is form of energy. So if I apply, I am having water again, I am having water, it's around 20 degrees centigrade. If I want to increase that temperature to 25 degrees centigrade, what will I do? I will apply the heat. Okay, so in that heat transfer, heat will be transferred from higher temperature region to lower temperature region in three ways. One is conduction, convection, and radiation. Okay, so conduction, it's like within the solid particles, due to the movement of the particles, what will happen? The heat will be transferred from one place to another place. It is a conduction. It will happen in solid medium. Convection, again, heat will transfer, but it happens in the liquid. So radiation means without any direct contact. Okay, the heat will transfer from one place to another place. You know the common application of it. Okay, how we are getting heat energy from the sun? By means of radiation. You all know that. Okay. So today we are going to discuss about one of the experiments called composite water. It is example for conduction. Okay. So you know that what is meant by conduction, and in that conduction you will having a property called thermal conductivity. Okay. So basically, in conduction we will say the property called thermal conductivity means it is the ability of that particular material to conduct heat from one place to another place. Okay, so that is called thermal conductivity, and it will vary from the material to material. It is not constant for all the materials. Depending on the material, thermal conductivity will vary. For example, steel will have higher thermal conductivity when compared to wood. Clear? Yes. So this is the composite wall experiment. Here we are having a sandwich kind of a thing. Okay, so totally 3 layers will be here. Give me a note, I will explain. Okay. So for example, this is the upper layer. Okay, upper layer consists of wood. Okay, and this is the middle layer, and middle layer consists of asbestos. And this is the third layer. This is called mild steel. So this is the kind of a sandwich. So upper layer is wood, middle layer is asbestos, and the third layer is mild steel. Okay. After that we will be having a heater, and again it will follow like as the material like mild steel, asbestos and wood. Okay. So heat will be transferred in both the ways, both upward as well as downwards. Okay. And this, what we are going to do is we are going to measure the thermal conductivity of these three materials. It will act as a single material. Even though we are having three different materials, this will consider as a single material, that is called composite. That is why we are calling as a composite one. Okay. So in this experiment, what we are going to achieve, we are going to calculate the thermal conductivity of these a single component called composite. Okay. So first you have to switch on this main switch. Okay. After that you have to vary the current. So take voltage of up to 80. Then you have to wait for a certain period. Okay, because this period will allow the heat transferring of heat from the center portion to upward and downward. Okay, so this is called a buffer time or buffer time. So we are giving a time for the transferring of heat from one place to another place. Okay. So after that, what we are going to do is we are going to measure. So here there are 5 different places are there where we are going to measure the temperature of it. Okay. So this is a T1. The temperature is 31, and if you switch this to 2, it is called temperature 2. This is 3. So the temperature will vary. Okay, and this is 4. If the temperature drop down means the heat is transferring to wood. Okay, so comparing to previous ones, all will rise. Okay, 31 to 34, 34 to 42. Okay, because at the center we are having mild steel. So eventually the mild steel having a higher thermal conductivity, so that heat will transfer more. Whereas when it goes to asbestos thermal conductivity is lesser when compared to mild steel. Automatically the transferring of heat is reduced. Then if it goes to the wood, again heat transfer, thermal conductivity is very low again. Also the heat transfer will be less. Right? So once you move higher, the temperature will drop down. Okay, like 30. So that means we are calculating the temperature of wood. So this is the experiment. With this we are going to calculate the thermal conductivity of this composite material. Am I clear?
Yes, sir.
So after that, we switch back to the T1. Okay. Then reduce the voltage into 0 and switch off the main heater. So this is the experiment that you are going to do. Am I clear?
Yes.
Thank you. Any doubts?
The temperature, 5 types of temperature, are the places that measure.
So here you can see the thermocouples are placed here,
Okay.
right at the wood, asbestos and mild steel.
Okay.
So there are 6 different places where you find the thermocouples. That thermocouples will measure the temperature.
So what is the use of meters?
So this is ammeter and voltmeter. That's the difference. So with this you are going to calculate based on the readings. You are going to calculate the thermal conductivity, and you have a formula in your manual, so you can easily calculate.